In this video, we introduce relative velocity. Relative velocity. Before introducing relative velocity, we have to introduce the frame of reference. Frame of reference is a coordinate system, and relative to the system, motion is described or observed. After knowing the frame of reference, we can introduce relative velocity. Relative velocity is the velocity of an object relative to a specific frame of reference. In fact, all velocities are relative velocities. There is no such a thing as absolute velocity. So when we investigate velocities, first we have to choose a frame of reference or frames of reference. Then we investigate velocities relative to the frame of reference or frames of reference. In some videos before this video in this channel, we have questions about velocities, but in these videos, we didn't mention the frame of reference. In fact, in these videos, the frame of reference is just a coordinate system fixed with the Earth. So now we know frame of reference, we know relative velocity, and we know that all velocities are relative velocities. There is no such a thing as absolute velocity. How to express relative velocities? The answer is subscripts in capital letters. For example, we can use this symbol to express the velocity of an airplane relative to the Earth, or in other words, the velocity of an airplane relative to the coordinate system fixed with the Earth. Here, P represents the airplane, and E represents the Earth. So we look at here. The object is on the left and the frame of reference is on the right. Similarly, we can use this symbol to represent the velocity of an airplane relative to the air, or in other words, the velocity of an airplane relative to the coordinate system fixed with the air. Here, P represents the airplane and A represents the air. And similarly, we can use this symbol to represent the velocity of the air relative to the Earth. The object is on the left and the frame of reference is on the right. And these three velocities have the relationship. The velocity of the plane relative to the Earth equals the velocity of the plane relative to the air plus the velocity of the air relative to the Earth. So here notice that on the left it's the velocity of the plane relative to the Earth. The p is on the left, and here p is on the left of the first velocity, and on the left e is on the right, and here e is on the right of the last velocity, and here a is on the right of the first velocity, and a is on the left of the second velocity. So this is the pattern, and the pattern can be expanded. For example, the velocity of A relative to D equals the velocity of A relative to B plus the velocity of B relative to C plus the velocity of C relative to D. Again, on the left, A is on the left, and on the right, A is on the left of the first velocity, and on the left, D is on the right, and on the right, D is on the right of the last velocity, and B is on the right of the first velocity, and B is on the left of the second velocity. C is on the right of the second velocity, and C is on the left of the last velocity. So this is just the pattern.